Welcome to Sundar's lecture. This is lecture number 91, and in this lecture we are going to see basics of three-phase circuits, right? We have seen single-phase circuit, single-phase AC and DC. We have seen already all those kind of things, and in this particular lecture or in this bunch of lectures, we are going to see basics of three-phase circuits. And we know this is nothing but a single-phase voltage, right? So we have a time axis here and a voltage axis. So it starts from 0 and it is just going like this, following the sinusoidal waveform, right? So now we know that V will be is equal to, we know these kind of things, right? V will be is equal to Vm sine of omega t, sine of omega t, right? We know this formula. And also see, if this is the Vs, that means the source voltage, make it as Vs. So this voltage has been connected to an impedance like this, then we can write that Vs will be is equal to V RMS at an angle of 0 degree, right? Because it starts from 0, so we will write as VRMS at an angle of 0 degree. And we know that the formula for I will be is equal to Vs divided by Z. This is it, right? And we know these kind of things. And also we can write power formula. P will be is equal to V into I cos theta. And also see, if this is Z, and then Z will be at an angle of some theta, right? If it is an inductive load, then it will be Z will be is equal to R plus Jx, and if it is a capacitive load, then it will be R minus Jx, right? So all those kind of things we have already studied. And also Q, what is P here? So this is Vi sin theta. See, what is P here? P, this is nothing but real power. This is real power, right? And this will be reactive power. Reactive power, right? We have seen these kind of things already. Anyhow, I just want to tell you again what is the basics of a single phase system, right? And also we know what is S here. S will be is equal to P plus JQ. This is nothing but, what is this one? This power is nothing but apparent power, right? Apparent power. We know this one, apparent power. And this apparent power can be also written as what? S can be also written as V square divided by Z star, right? Z star, or S can be also written as Vi star. So many formulas we have already studied, right? These basics are already, we know these kind of things, right? So this is single phase AC system, right? Now we need to know what is the basics of three phase AC system, right? That we will see now. See, we will take an example like this. This is actually a house wiring. See, where we can connect a line and a neutral, which means this is phase and a neutral. We will call it like that. And we will connect an fuse, and we will have a meter to read energy, and we will have a main switch, fuse, and then we will connect the bulb like this, right? From a phase, you will take a wire and put a switch, and then it is connected to the bulb, and neutral will be directly connected to the bulb. And also if you have a socket like this, then the phase will be connected through a switch, and the neutral will be directly connected, right? And then there will be an ground wire, and this ground wire will be connected to these kind of sockets, right? This is how you would have connected the single phase systems we are using at commercial usages, right? In commercial house wirings and so many places, we use these kind of single phase AC systems. But you see, it never comes from a single phase system. Actually, it is a three phase. I will explain you a bit later. From three phase 4 wire system, we will take the single phase, right? They will not give you directly a single phase. You would have taken from a three phase 4 wire system as a single phase, right? That we will see after this one. See the next one. This is nothing but a three phase voltage generation part. See here, you have three phases, right? Because this is three phase, you have R phase, Y phase, and then B phase, right? So this R phase, which means here it has shown like a single phase system, single R phase, and single Y phase, single B phase, right? We have three different phases, but we never connect like this. We never connect like this. Either we have to connect it by star or we have to connect it by delta. And we will see both things. See, this is the graph now. See, this VR, which is nothing but we will always take this VR as the reference phasor, because you see it starts from 0. It always starts from 0, so that we will take this as the reference phasor. And this phase, that is Y, so you can see here this Y, this is nothing but this is minus 120 degree here actually. So here you see this will start from minus 120 degree. So this R phase will this Y phase lags the R phase by 120 degree, like that. And then you see this point, this is nothing but plus 120 degree, which means this B phase, this is actually B phase, this B phase leads the R phase by 120 degree. Always you see the three phases R, Y, B are all separated by 120 degree, are all apart by 120 degree. I will show you how these kind of things will happen and what is the reason behind those kind of things, right? So now how we are going to connect this one. See, you have three different connections. This one, three phases are there, and I can take this as now R, and this is R1, this is Y, this is Y1, this is B, and this is B1. What we are going to do here, we are going to connect all R1 with Y1, and then this Y1 will be also connected to B1. And you see we will take output from here. This is R, this is Y, and this will be B. See, this connection, we generally call these kind of connections as star connections. Star connection. Why it is star connection? See, this connection I can redraw in a different way. Right? This one. This will be like this. One phase. And then you can draw another phase like this. Maybe like this, and then you draw another face like this. See, I can easily write this is now R, and then R1, this is now Y, this is Y1, and this is B1, like this. And if you take out this will be R, and this will be B, and this will be Y. Maybe RY. Maybe you take this as BRY, no problem whatsoever. We will connect all the R1, B1 and Y1 to be at a single point. We will call this point as a neutral point. Either we have three phase, three wire system in star, which means R, Y, B only there, or you can connect this neutral point. I will explain you what happens if you connect neutral point. All the currents become zero at the neutral. If the supply is balanced, all those kind of things we will see one by one, right? So this is nothing but a star connection, and R will be the reference phasor, and Y will be lagging by 120 degree, and B will be leading by 120 degree, which means you see this is the R phasor, this is the R phasor, and this is the B phasor, and this will be Y phasor, which means you see this is R, this is Y, and this will be B. See, what is the angle between these two? This will be 120 degree, which means if you going in the anti-clockwise direction, then this Y is lagging the R by 120 degree, and then you can write like this B actually leading R by plus 120 degree, and you see what is the angle between these two? Simply it is 240 degree, then the whole rotation will be 360 degrees. So angle between these two will be 120 degree. Or you see, you can write like this. This is actually minus 120 degree. These two will be minus 120 degree, and also if you write these two in this way, then you can write it as this is minus 240 degree. That also possible. Either it will be plus 120 degree, or you can say if it is lagging, then it will be lagging by minus 240 degree. That is the whole idea, right? So this is nothing but a star connection, and then we will see what is delta connection. Now see, the same connection we have taken, the same thing. This is R phase, Y phase and B phase, right? We have three phases, right? Now we have three phases. This is one phase R, and this is one phase B, and this is now one phase. This R, Y, B, right? So how will you write this one? This is R, R1, Y, Y1, B, and then this will be B1. And now what we will do, we try to connect these two now. These two has to be connected, and these two has to be connected. That's all. Now you see, you take a point from this point, from R, and then from Y, and then from B. Nothing but we will call this as now R, Y, and then B. That is the supply system. See how this is actually connected. See, this one is actually connected like this. Like this. See, you have plus minus, right? This is plus, let it be minus, right? That is what we have taken here. This is plus, minus, this is plus, and then this is minus. And now you see this point, this will be now point, this has to be taken as R, and this has to be taken as R1. This R1 is connected to where? This R1 is connected to Y, and this should be Y1. And this Y1 is connected to where? B, right? This maybe 1 minute. We will change this. Okay, right? We will write it down. This is R1, and this R1 is connected here, right? This is Y, and this can be connected as Y1, and then this Y1 is connected to B, right? So this will be B, and this will be B1, so that this B1 will be connected to R here. So this will be now R phase, this will be B phase, and this will be Y phase. This will be Y phase, right? This is nothing but R, B, and then this is Y. And the same thing, you don't have a different phasor diagram. This is R, this is Y, and this will be B. Again, the R will be the reference phasor. If R is reference, then obviously B will come by minus 120 degree. Minus 120 degree, sorry, Y will come by minus 120 degree, and B will come by plus 120 degree. That is the difference. But in star connection, we will call this as delta connection. Delta connection. So this is how we will connect a delta connection in a three-phase voltage generation system. So star and delta, in both cases, the phasor diagram will be like this. Maybe I will draw here. If this is R, then Y will be here, and then B will be here. That's all. Like this. So if this is R, if this is Y, and if this is B, then obviously this will be 120 degree, which means this is in negative, so minus 120 degree. Then this will be plus 120 degree. And if you write like this, if the angle between these two will be minus 240 degree. All these kind of things are same, right, as a star connection. And we have two different connections, one is star and one is delta. Both have the phase angles between the R phase, Y phase and B phase will be same, right? This is how we will take it out as a connections. And you see, now we will see what is a balanced voltage. See how we will write this expression. It is very simple now. Make it as ER. Now ER can be written as EM sine of omega t, sine of omega t. This is nothing but the reference phasor. Since it is reference phasor, we don't have any phasor angles, right? So how I can write now EY? So we know, right? So EM sine of omega t minus 120 degree, because that is Y phase. This is Y phase. This is minus 120 degree, and EB can be written as EM sine of omega t minus 240 degree, or you can write this expression as Em sine of omega t plus 120 degree. Both are same. Both are same. Right? Now you see, if you add all these values, E should be is equal to ER plus EY plus EB. If you do so, this value becomes 0. Why? Because you add this one, you just use sine of A minus B formula or sine of A plus B formula and substitute all the values. Obviously, you will get 0. See, try to understand. This is called this this procedure, or maybe this uh, phenomena, we are calling it as balanced voltage. If the voltages, if the magnitude of voltage are same, see EM, all the magnitude of R phase, Y phase and B phase are same, and every phases are apart by 120 degree, are placed by 120 degree in a phasor angles, then the system, we will call this as the balanced voltage system, right? Even you can write this in phasors, right? What is VR? Maybe in phasor, in phasors if you write, then it will be EM by root 2 at an angle of 0 degree. Why I am doing this one by root 2? To convert this into a VRMS value, right? Always if you are writing it in a phasor, then this value should be a RMS value, right? So VY should be is equal to EM divided by root 2 at an angle of minus 120 degree. And also if you want to write VB, then it should be is equal to VM by root 2 at an angle of minus 240 degree, or we can write it as EM by root 2 at an angle of plus 120 degree, right? So if you draw the diagram now, so if this is R phase, then this will be Y phase and this will be B phase. And what is the angle? So this is VR, this is VY and this will be VB. So what is the angle? This angle will be minus 120 degree and this angle will be plus 120 degree. And if you want to write what is this angle, then this is minus 240 degree. And angle between these two will be also 120 degree. See, everything comes as a picture, like this is the diagram for the phasor of VR, VY and VB. Everything will be 120 degree apart, right? You try to understand these kind of things. So this is nothing but a balanced voltage. If it is a balanced voltage, then obviously VY will lax the VR by 120 and VB will lax VR by 240 degree or leads by 120 degree. That is the whole idea, right? Now we will see what is the unbalanced supply system. And now you see this is nothing but a load side, right? So we can see balanced load. This is nothing but a balanced load. See, in load side also you have two types. One is star connected load and one is delta connected load. Everything will be same. See, you have Z in all the in all the phasors. In all the phasors you have Z and then Z, which means you have to give a supply here and this load will be connected like this, right? Supply system we have already seen, and now this is nothing but the load system. And in load system also the loads can be connected either in star or it can be connected in delta. And you see this is actually star and this is nothing but delta. Don't try to confused, because this is not related to this graph, this is not related to this graph, this is a separate part. See, this is nothing but a balanced load, this is nothing but a balanced load. See, why we are calling this as balanced loads, try to understand. You see this IR this IR phase, which is nothing but the value of magnitude of I phase at an angle of 0 degree. This one, if you take this as the reference. And if you see this IY, this IY will be is equal to what? I phase at an angle of minus 120 degree, because the if you take the magnitude as same, then if you write IB, then IB can be written as I phase R at an angle of minus 240 degree, or you can write it as IP phase magnitude of the value plus 120 degree. If it is so, so minus 1 0 minus 20 minus 120 minus 240, then this load can be considered as balanced load. And you see, this is nothing but unbalanced load. That is why I want to differentiate both balanced load and unbalanced load. Why? You see here, the R phase is, if you take this as the reference phase, then you will have IR value to be I phase at an angle of 0 degree. If I am taking this as reference, then IY to be I phase at an angle of minus 100 degree, right? This is minus 100, and if I write IB, then IB I will write it as I phase R at an angle of 160 degree. See, there is no 120 degree partition between the phases. R phase and Y phase and B phase. It has 160 degree, it has 100 degree, it has 100 degree. Then we can consider these types of load are unbalanced load, which means the values of Z in every phases, either it will change by magnitude, or it would have been changed by the phase angles. Here they have shown as they have just changed by the phase angles, not by the values of magnitude. If magnitude are kept constant, even though magnitude are constant, it has to be 120 degree apart. Then only we will call it as balanced load. Unless if it is both magnitude and the phase angles are 120 degree, then we never call the load to be balanced, right? You have to understand the difference between balanced load and unbalanced load. And the next topic, it is nothing but 3-phase 3-wire system and 3-phase 4-wire system. You see, this is R phase, Y phase, and then this is B phase. The supply system is now connected to the load side. This is load, this is supply, this is nothing but supply side, and this is nothing but load side. I have told you, supply side has star or delta, and the load side may be star or delta, but here it is supply side is also star, and the load side also star. You see here, this neutral point would have not connected in the supply side and the load side. These types of connections we generally call, this is 3-phase 3-wire system. Only we have 3 wires, and this part we can call it as 3-phase 4-wire system. See, supply system, supply is star and also load is star here, and then these two neutrals will be connected between star and the load. So that we are calling this as the 3-phase 4-wire system. And this 3-phase 4-wire system, which is nothing but we are using commercially. See, if you see any supply lines coming to your home, it will be 3-phase 4-wire system, where R phase will be there, Y phase will be there, B phase will be there, like this R, Y, B, and it will have a neutral point. So that what you can do there, you can connect it as a single phase. If you take a single wire from, you can connect 3-phase also. See, induction, if it is 3-phase induction motor, then obviously you see R, Y, B will be there. You can directly connect R, Y, B, so that this 3-phase induction motor will run. And if you want to connect a single phase load like a fan or TV or a light, those kind of systems, so what we can do, we can connect a single phase, one phase, and we can connect it from the neutral. So this is called the advantage of the 3-phase 4-wire system. We can use it for commercial purposes, and you can also use it as a single phase system. So that is the difference between 3-phase 3-wire system and 3-phase 4-wire system. See, if you want to run only induction motor, if you don't want to run these kind of loads, then 3-phase 3-wire system is more than enough, right? Because you don't need neutral here. But if you want to use it as a single phase systems, then you should have 3-phase 4-wire system, right? That is the difference between these two. See, the next one, if you take this 3-phase 4-wire system, if you are considering that the supply system is balanced and the load will be also balanced. See, you have ZLO, right? So let this ZLO to be Z at an angle of pi, Z at an angle of pi. If you are taking like this, then if you apply KVL, you apply KVL for each loop. For each loop, for example, for this loop, if you are applying KVL, make it as this is plus and this will be minus. If you are going for VR from minus to plus, you have to travel, right? So I'm traveling from minus. So I am traveling in this direction. This current is coming opposite to me. So it will be IR into ZLO, right? ZLO, I have came to this point. So if you are writing IR, then IR will be is equal to what? VR divided by what is ZLO, which is nothing but it is Z at an angle of pi. See this one, what is the value of VR? VR nothing but we will take it as the reference phasor, So VP at an angle of 0 degree divided by Z at an angle of pi. So that I will get it as now VP, maybe I will take it as IR, this VP divided by Z, that is nothing but I am taking it to be IR, maybe I phase IP at an angle of 0 minus pi. This is the value of IR, right? And if you are going for VB, likewise VB, if this is plus and this is minus, and if you write down this, you will get this value. So VB divided by Z at an angle of pi. And what is VB? We know that VB, which is nothing but it is V phase at an angle of minus 1 B phase, right? B phase means it is plus 120 degree divided by Z at an angle of pi or YB, right? So this value, so VB can be written as what? It can be written as, sorry, this is not VB, this one, what is this one? It is actually IB, right? It is actually IB. So what you will get? So IB will be is equal to I phase at an angle of 120 degree minus pi. So VP by Z nothing but I am taking it to be IP. And also if you go for IY, then it will be VY divided by Z at an angle of pi. So what is Y? So VY will be always minus 120 degree divided by Z at an angle of pi. So what I will get, then IY will be is equal to IP at an angle of minus 120 degree minus pi. So if you draw the diagram, if you draw the phasor diagram again, so this will be like this and this will be like this. So what is the values here? So this will be IR, this will be IY and this will be IB. And what is this angle? This is 120 degree. And what is this angle? Minus 120 degree. This is plus 120 degree. Right? This is actually happening. And if you add all these things, what happens to IY plus IB plus IR, and that should be is equal to IN, right? Neutral current, this neutral current, and that should be is equal to 0. If you add all these IY, IB, IR, everything becomes 0. So try to understand one thing: at balanced circuit, circuit, at balanced circuit, what happens to the neutral current? IN should be is equal to 0. And what is IN? IN, which is nothing but it is IR plus IY plus IB. So at balanced circuit, all the current, if you add all the phase currents, then it has to be 0. And that is nothing but the neutral current. Right? If you have any neutral current, then the circuit will not be a balanced one. Right? This is the basics of three-phase circuits. And in the next lecture, we will see what is star connection and what is delta connection and what is the line current and line voltages, phase current and phase voltages in star and delta connections. And we will take some more examples and try to understand the concepts of star connection and delta connection, right? Thank you. We will see in the next class.